On September 5, 2022, something unexpected happened 23 billion kilometers from Earth. Deep in the cosmic void, where sunlight takes over 21 hours to arrive and appears no brighter than a distant star, NASA's Voyager 1 spacecraft began transmitting data that left scientists speechless. The probe, humanity's most distant ambassador, was sending a message from the edge of everything we know. And what it revealed challenges everything we thought we understood about the boundary between our solar system and the infinite darkness beyond. This is the story of a mystery unfolding at the frontiers of human exploration, where a machine built in the 1970s continues to whisper secrets from a place no human eye will ever see. What Voyager 1 discovered out there in the interstellar void is both terrifying and magnificent. And it all begins with understanding just how far from home this lonely traveler has journeyed. When Voyager 1 launched from Cape Canaveral on September 5, 1977, its primary mission seemed almost modest by today's standards. NASA designed it to perform close flybys of Jupiter and Saturn, capturing detailed images and scientific data that would revolutionize our understanding of these gas giants. The spacecraft carried 11 scientific instruments, a suite of cameras, and perhaps most famously the Golden Record, a time capsule of Earth's sounds, music, and images intended for any intelligent life that might one day encounter it. But the engineers at NASA's Jet Propulsion Laboratory had embedded something extraordinary into Voyager's trajectory. By carefully timing the launch and using a rare planetary alignment that occurs only once every 176 years, they gave Voyager 1 the ability to use gravitational assists from each planet it encountered. This cosmic slingshot effect would eventually propel the spacecraft beyond the orbits of all known planets, sending it on a one-way journey into interstellar space. The mission succeeded beyond anyone's wildest expectations. In 1979, Voyager 1 revealed Jupiter's complex atmospheric dynamics, discovered active volcanoes on its moon Io, and captured stunning images of the planet's turbulent cloud bands. By 1980, it had performed its Saturn encounter, discovering new details about the planet's rings and examining the mysterious Moon Titan with its thick, nitrogen-rich atmosphere. Each discovery rewrote textbooks and expanded humanity's understanding of our cosmic neighborhood. But then came the decision that would transform Voyager 1 from a planetary explorer into something far more profound. After completing its primary mission, NASA made the bold choice to keep the spacecraft operational and send it upward, out of the plane of the solar system, toward the constellation Ophiuchus. The trajectory would take Voyager 1 through completely uncharted territory, into regions of space that existed only in theoretical models and mathematical predictions. As the decades passed and Voyager 1 continued its solitary journey, it became clear that this spacecraft was destined to become humanity's first interstellar probe. Every year, it traveled approximately 3.6 astronomical units farther from the Sun, moving at a speed of about 17 kilometers per second relative to our star. The distance grew so vast that radio signals from the spacecraft, traveling at the speed of light, took increasingly longer to reach Earth. By the 2020s, communications required over 42 hours for a round trip, a conversation stretched across more than 20 billion kilometers of emptiness. To understand what Voyager 1 encountered at the edge of the solar system, we need to grasp the true nature of the boundary it crossed. The solar system doesn't end with a clear-cut edge like a planetary atmosphere. Instead, it's defined by the influence of the solar wind, a continuous stream of charged particles that the Sun blasts into space at speeds exceeding 1 million kilometers per hour. This solar wind creates a protective bubble around our solar system called the heliosphere, shielding us from the harsh radiation and cosmic rays that permeate interstellar space. The outer boundary of this heliosphere is called the heliopause, and it represents one of the most dramatic transitions in our cosmic neighborhood. Inside the heliopause, the environment is dominated by particles from our Sun, the familiar solar wind that has shaped the conditions throughout our solar system for billions of years. But beyond this boundary lies something entirely different. The interstellar medium, a sea of particles, radiation, and magnetic fields that exist between the stars. Scientists had theorized about the heliopause for decades. But until Voyager 1 actually reached it, no one knew exactly where it was or what crossing it would be like. The journey toward this boundary took Voyager 1 through another significant region called the heliosheath, a turbulent zone where the solar wind begins to slow down and compress as it encounters the pressure of the interstellar medium pushing back against it. This region extends for billions of kilometers and represents a complex dynamic boundary layer between two fundamentally different cosmic environments. The physics of this boundary fascinated scientists because it involves the interaction between two powerful forces: the outward pressure of the solar wind, and the inward pressure of interstellar space. These forces create shock waves, turbulent plasma dynamics, and magnetic field distortions that make the heliosheath one of the most complex environments in our solar system. Understanding these interactions helps scientists comprehend not just our own star's influence, but also how other stellar systems interact with the galaxy around them. As Voyager 1 ventured deeper into the heliosheath throughout the 2000s, its instruments detected strange phenomena. The cosmic ray subsystem measured increasing levels of high-energy particles called galactic cosmic rays, radiation from distant supernovae, and other violent cosmic events that the heliosphere normally blocks. Meanwhile, measurements of solar particles began to decrease, indicating that the spacecraft was approaching the edge of the Sun's direct influence. The transition was gradual, not sudden, a slow fade from one domain to another. Then, on August 25, 2012, Voyager 1 made history. After traveling for 35 years and crossing more than 18 billion kilometers of space, the spacecraft definitively crossed the heliopause and entered interstellar space. The moment was confirmed by a dramatic drop in solar particles detected by the spacecraft's instruments and a corresponding surge in galactic cosmic rays. For the first time in history, a human-made object had left the solar system's protective bubble and entered the space between the stars. The significance of this achievement cannot be overstated. Voyager 1 became humanity's first interstellar spacecraft, our first physical presence in the true depths of space beyond our Sun's influence. Every measurement it transmitted after crossing the heliopause represented data from a place no instrument had ever explored. Genuine interstellar space, the medium that fills the vast distances between stars and makes up the majority of our galaxy's volume. But crossing into interstellar space didn't mean Voyager 1's mission was over. In fact, the most intriguing discoveries were yet to come. The spacecraft continued to transmit data about the density, temperature, and composition of the interstellar medium, revealing that this space between stars is far from empty. It contains approximately 1 atom per cubic centimeter, an environment trillions of times less dense than Earth's atmosphere but still complex and dynamic, filled with magnetic fields, cosmic rays, and the remnants of ancient supernovae. What scientists discovered challenged many expectations. The interstellar magnetic field proved stronger than predicted, and the boundary region was more turbulent and complex than theoretical models had suggested. The temperature of the interstellar medium measured far hotter than anticipated, hundreds of thousands of degrees, though the extreme thinness of the material meant it couldn't transfer heat in any conventional sense. Each discovery required scientists to reconsider their models of how stellar systems interact with the galaxy at large. And then came September 2022, when something truly unexpected occurred. NASA engineers noticed anomalies in the telemetry data coming from Voyager 1's Attitude Articulation and Control System, or AACS. This critical system is responsible for keeping the spacecraft's antenna pointed precisely at Earth, an absolutely essential function given that Voyager's signals are incredibly weak by the time they reach our planet. The AACS appeared to be working perfectly, the antenna remained locked on Earth, and the signal strength was normal. But the data describing the system's status didn't match the spacecraft's actual behavior. The telemetry readings appeared to be randomly generated, or they reflected a state that was physically impossible given the spacecraft's known orientation. It was as if Voyager 1 was reporting information from some alternate reality. Data that couldn't possibly be true yet was being transmitted with apparent sincerity. Engineers at the Deep Space Network stations that communicate with Voyager received these contradictory signals with growing concern and fascination. For months, NASA's engineering team at JPL worked to diagnose the problem. They sent commands to the spacecraft, waited over 42 hours for responses, and carefully analyzed every piece of data. What they eventually discovered was both a relief and a revelation. The AACS itself was functioning perfectly. However, the system had begun sending its telemetry data through an onboard computer that had failed years earlier, the flight data subsystem. This faulty computer was corrupting the data before transmission, scrambling it into the nonsensical readings that had puzzled engineers. But here's what makes this story truly remarkable. The fact that Voyager 1 was able to route data through a failed computer and still maintain contact with Earth demonstrates the extraordinary robustness of its design. Engineers from the 1970s, working with technology less powerful than a modern smartphone, built redundancy and flexibility into systems that would need to function for decades in one of the harshest environments imaginable. The spacecraft adapted, found an alternate pathway for its data, and continued its mission despite operating far beyond its design lifetime. By May 2023, NASA successfully sent a software patch to Voyager 1, instructing the AACS to route its telemetry through the correct computer pathway. The fix worked. Clear, accurate data began flowing again from the spacecraft. But the incident raised profound questions. How many other systems on board Voyager 1 might be degrading or failing in unexpected ways? What other anomalies might emerge as this ancient spacecraft continues its journey through an environment no engineer could have fully anticipated? The mystery of the garbled telemetry speaks to a larger truth about Voyager 1's situation. It operates in absolute isolation, in conditions that cannot be replicated or fully tested on Earth. The temperature hovers around -180 degrees Celsius. Cosmic radiation constantly bombards its electronics. Its power supply, a set of radioisotope thermoelectric generators, produces less electricity every year as the plutonium-238 inside naturally decays. By the mid-2020s, Voyager 1 generates only about 60% of the power it had at launch. NASA engineers have had to make difficult decisions about which instruments to keep running and which to shut down permanently to conserve power. The cameras that captured those iconic images of Jupiter and Saturn were turned off in 1990 after taking the famous pale blue dot photograph of Earth from 6 billion kilometers away. Other instruments have been deactivated over the years, including the ultraviolet spectrometer and the infrared radiometer. Each shutdown is carefully calculated to preserve the most scientifically valuable instruments for as long as possible. Current projections suggest that Voyager 1 will have enough power to operate at least one scientific instrument until approximately 2025, with some estimates extending to 2030 if additional systems can be shut down. After that, the spacecraft will continue its journey in silence, unable to communicate with Earth but carrying the golden record into the depths of space. It will drift through the galaxy for millions or even billions of years, a time capsule of human civilization traveling among the stars. But let's pause for a moment and consider what Voyager 1's journey really means. Not just scientifically, but philosophically. Right now, this spacecraft exists in a realm of unimaginable loneliness. If you could somehow travel to Voyager 1's location and look back toward our solar system, the Sun would appear as nothing more than a bright star, indistinguishable from countless others scattered across the sky. Earth would be completely invisible, lost in the glare of our star, separated from you by a gulf of darkness so vast that light itself takes a full day to cross it. There are no reference points out there, no planets to use for navigation, no familiar constellations to orient yourself. The spacecraft flies through an endless night, surrounded by the faint glow of distant stars and galaxies, the only human presence in a volume of space larger than most people can comprehend. The silence is absolute. No air exists to carry sound. No solar wind buffets the hull. Just a cold, empty medium between the stars and the steady, patient hum of Voyager's systems continuing their assigned tasks. I'd love to hear your thoughts on this. When you imagine Voyager 1 out there in the darkness, 23 billion kilometers from home, what emotion does it evoke? Do you feel awe at humanity's achievement? A sense of melancholy for this lonely traveler? Or perhaps wonder at what it might still discover? Drop your thoughts in the comments below. And if you're finding this journey as fascinating as I am, hit that like button. It helps us share these incredible stories with more people who appreciate the profound beauty of space exploration. The story of Voyager 1 doesn't end with its current mission. In fact, the spacecraft's longest journey is still ahead. In approximately 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, a small red dwarf in the constellation Camelopardalis. This is a distance that might seem close in cosmic terms, but it's still nearly 10 trillion kilometers, far enough that Voyager will have no significant interaction with the star or any planets that might orbit it. Over the millennia, Voyager 1 will continue its orbit around the galactic center, completing one full circuit approximately every 225 million years. It will witness, in its silent way, the slow evolution of stellar neighborhoods, the birth and death of stars, and the gradual transformation of our galaxy. If the spacecraft somehow survives long enough, it might even be around when the Milky Way begins its collision with the Andromeda Galaxy in approximately 4 billion years. Though by then any trace of the civilization that built it will likely be unrecognizable or gone entirely. Meanwhile, NASA continues to monitor Voyager 1 as long as power permits. Every piece of data it sends back provides insights into the nature of interstellar space. Scientists have discovered that the density of the interstellar medium varies more than expected, with Voyager detecting waves and disturbances in the plasma that surrounds it. These measurements help astronomers understand the structure of the local interstellar cloud through which our solar system is currently traveling, a region of slightly denser material that will remain inside for tens of thousands of years. The spacecraft's plasma wave subsystem has detected emissions that reveal information about the electron density in interstellar space. These plasma oscillations occur when disturbances in the interstellar medium create waves that propagate through the ionized gas. By measuring the frequency of these oscillations, scientists can calculate the density of electrons and, by extension, understand the overall structure and composition of the space between stars. It's humbling to realize that a machine built before personal computers were common can still provide cutting-edge scientific data about one of the least understood environments in our galaxy. There's also a profound legacy aspect to Voyager 1's mission. The golden record attached to the spacecraft contains 116 images, a variety of natural sounds from Earth including whale songs, wind, thunder, and birds, musical selections from different cultures and eras spanning Beethoven to Chuck Berry, and spoken greetings in 55 languages. It represents an optimistic message from humanity to the cosmos, a declaration that we existed, we created art and music and science, and we hope that someday someone might find this and know we reached out to them. The chances of the golden record ever being found are astronomically small. Space is unimaginably vast, and Voyager 1 is tiny by comparison. But the act of including it wasn't really about the likelihood of discovery. It was about the statement it makes about humanity itself, that even in the infancy of our space age, we thought about our place in the universe, we considered the possibility of other intelligent life, and we wanted to share the best of what we are. Looking forward, Voyager 1's discoveries about the heliopause and interstellar space are shaping future missions. NASA and other space agencies are planning dedicated interstellar probe missions that would travel much faster than Voyager, potentially reaching the heliopause in just 15 to 20 years and then continuing into deeper interstellar space. These missions would carry more advanced instruments designed specifically to study the boundary regions and the interstellar medium, building on the foundation that Voyager has established. One proposed mission concept involves using solar sails or even nuclear propulsion to achieve speeds several times faster than Voyager's velocity. At such speeds, a probe could reach truly distant regions of interstellar space within a human lifetime, potentially studying multiple stellar systems or exploring the structure of the local galactic environment in ways that Voyager simply cannot given its relatively slow pace. But for now, Voyager 1 remains our only active emissary in interstellar space, our sole working representative beyond the Sun's protective bubble. Every day that it continues to function and transmit data is a gift, an extension of a mission that has already exceeded expectations thousands of times over. The engineers who designed this spacecraft in the 1970s could never have imagined it would still be operating in the 2020s, still sending back data, still expanding human knowledge from the edge of everything we know. So what does Voyager 1's strange message from deep space really tell us? It tells us that even our most carefully engineered systems can behave unpredictably when pushed beyond their design limits. It reminds us that space exploration is always an venture into the unknown, where surprises await even from spacecraft we've worked with for decades. It demonstrates the incredible ingenuity of engineers who can diagnose and fix a computer problem on a spacecraft 23 billion kilometers away using 1970s technology. But perhaps most importantly, it tells us something profound about human curiosity and persistence. We built this machine and sent it on a one-way journey into the dark, not because we had to, but because we wanted to know what was out there. We've maintained contact with it for 47 years, not because it's easy or profitable, but because the knowledge it provides expands our understanding of the universe and our place within it. The mystery of Voyager 1 isn't just about garbled telemetry or strange data from the heliopause. The real mystery is what this lonely spacecraft represents, a testament to human ingenuity, a symbol of our desire to explore, and a physical manifestation of our hope that we are not alone in the universe, that our existence matters, and that reaching out into the darkness is worth the effort even if we never receive an answer. If this journey has moved you, if it sparked your imagination, or made you think differently about our place in the cosmos, I encourage you to subscribe to this channel. We're committed to bringing you more stories about NASA's incredible missions, the mysteries of space, and the cutting-edge science that's revealing the universe in ways previous generations could only dream about. Hit that notification bell so you don't miss our next exploration into the unknown. And before you go, share this video with someone who appreciates the profound beauty of space and the remarkable achievements of human exploration. Right now, as you watch this, Voyager 1 continues its silent journey through the interstellar void. Its antenna remains pointed toward Earth, a fragile thread of connection across billions of kilometers. Its instruments continue to measure and record, sending back data at an incredibly slow rate of 160 bits per second, less bandwidth than a telephone modem from the 1990s. But every bit of that data is precious, irreplaceable information from a place no human has ever been and no other machine has ever explored. The spacecraft carries no awareness of its significance. It doesn't know it's humanity's most distant creation or that billions of people have been inspired by its journey. It simply follows its programming, executing instructions from engineers who may no longer be alive, fulfilling a mission that has become so much more than anyone originally planned. In its way, Voyager 1 embodies the best of what humans can achieve when we dare to reach beyond our limitations, when we invest in knowledge for its own sake, and when we accept that some journeys are worth taking even if we'll never see their end. The message from Voyager 1 isn't terrifying because it reveals alien life or cosmic dangers. It's terrifying in a more existential sense because it confronts us with the sheer scale of the universe, the profound isolation that exists between the stars, and the courage it takes to send something we created into that endless night. But it's also magnificent, inspiring, and deeply human. We may be small and fragile creatures on a tiny world, but we had the audacity to reach across the cosmic void and touch the space between stars. And that is Voyager 1's true message from deep space. Not a warning or a discovery, but a reflection of who we are and what we're capable of when we dare to explore the unknown. This content is based on real NASA missions and scientific data, including the documented telemetry anomalies experienced by Voyager 1 in 2022. While the narrative is crafted for entertainment and educational purposes, all major facts about the spacecraft, its journey, and its discoveries are accurate as of the latest available information. Viewers interested in learning more are encouraged to visit NASA's official Voyager mission website and explore peer-reviewed publications about interstellar space exploration.